Good morning. My name is Pat Lord. I am the VP of Global Operations and the Customer Support Business Group at Lam Research. And I'm delighted to be here today, having the opportunity to present this keynote speech. And I want to thank SEMI for the opportunity to talk to you a little bit more about accelerating innovation, especially from lab to fab. And hopefully after the previous two speakers, I'd like to give you a little bit more of an equipment supplier perspective to some of these challenges. The pace of innovation has really been extraordinary if you look at it. But actually, if you look at human history, most of the innovation has really occurred in the past 150 years. And it's accelerating exponentially, both in terms of impact and scope. And it's probably going to continue to do this. So what used to take hundreds of years to fully achieve across the globe is now taking decades and sometimes even less. And I don't believe this will change. I think this will continue and continue to accelerate over time. So it's no surprise that as part of this innovation, the center of it is really fundamentally semiconductors and the semiconductor industry. Semiconductors and their innovation and the progress that they've made have really created this area of innovation across industries. From the original semiconductors with a few transistors of 70 years ago to some of the transistors or some of the chips with tens of billions of transistors, even sometimes hundreds of thousands, hundreds of billions of transistors on them. Semiconductors are creating new opportunities and creating an era of innovation for the entire industry. And I don't believe this will change. I do believe that semiconductors will continue to be at the center of our biggest challenges in terms of solving any of our problems in medical, in communication, in transportation, environmental challenges, and in any areas related to research or industrial. So this increased complexity and cost is really become the challenge slowing us down a little bit. This innovation is being faced in our industry with increased cost, increased complexity. The number of steps are growing exponentially. And the cost per wafer are growing as well exponentially, making it more and more challenging to continue on the space of innovation that we've been on. So what I would like to present to you is a little bit kind of some of the ideas of how to keep this space of innovation going, at least from an equipment maker's perspective, and where does it start? So at Lam Research, we believe on delivering on speed to innovation and on speed to solution. And it starts fundamentally in the lab. And when we talk about the lab, it's fundamentally the research centers that we've put around the globe to help with our customers in close proximity develop the next generation of manufacturing technologies for semiconductors. One such investment is the Korean Technology Center that we opened last year. It is one of our most advanced labs in the world, in close proximity to customers, as well as capable of holding some of our latest technologies in terms of deposition and etch. We're very proud of this investment. We believe that it is one of the ways we can reduce the cycle times of working with our customers on solving the biggest challenges associated with semiconductor manufacturing today. So let me introduce you a little bit more to this lab that we opened last year. by bringing our Korean technical team closer to the customer and equipping them with the latest technology that we have in the center of the K semiconductor belt in Korea, we really believe that we will have the opportunity to reduce cycle times, having customers as well as our customers, engineers and our engineers working together very closely, providing their rapid feedback on the solutions that we're developing, both in terms of process development as well as hardware development. We'll think that this investment of kind of this distributed lab R&D approach will help close kind of the gap, will help reduce the cycle time, also especially when wafers have to continue to be processed in our customers' fabs for full integration, ultimately, and full integration testing. So in addition to the benefits that we think we'll gain out of these localized R&D centers close to the customer, we also believe that this will help the entire ecosystem in Korea. It will help suppliers, it will help research universities, and research institutions, benefiting the overall Korean semiconductor ecosystem. Just to give you an idea, there are plans in Korea to increase the workforce by 150,000 people over the next 10 years, nearly doubling the number of people in Korea that are working in this industry. We think that private-public partnerships will be key to enable this growth in terms of quality and quantity of the workforce. And we think that a research center like the Korean Technology Center that we put in place here can be a key solution to making it happen. Now, beyond Korea, we've continued with this distributed approach to our R&D modeling, strengthening our R&D labs around the world, closer to our customers, tailoring them to the needs of our customers to help accelerate fundamentally the innovation in each of the disciplines, being memory, logic, analog, or even specialty technologies. We're going to continue to do this because we really believe that with this approach, we can accelerate globally the changes that are needed to keep on this pace of innovation that we've been in the past and kind of counteract some of the slowing down that we may have seen in recent years. So the rapid rise in technical complexity continues. The two speakers before me clearly highlighted the challenges with this technical complexity and the solutions that as semiconductor makers, they're thinking of coming through to make it happen. But there is a kind of an amazing evolution. If you just go back only 10 years, FinFETs were starting to be kind of in high volume production. NAND was planar, and DRAM was at the 36 nanometer node. 10 years later, we are pushing logic to 2 nanometers with gate-all-around and nanosheets. We are pushing over 300 layers of 3D NANDs, stacked 3D NAND. And we're on the verge of moving DRAM to 3D as the continued economic scaling of planar 2D is starting to show signs in DRAM of these challenges. So very rapid change in just 10 years alone, and I think this will continue. And in order to make some of these changes happen, they will not happen just naturally. Let me just talk to you about 3 technologies that we believe at Lam are likely to become kind of enabler to keep kind of the space of innovation going and enable some of the breakthroughs that we are looking for over the next several years. Dry resist is one such technology. It is a transformational technology. As you know today, most lithography, the resist is spun wet and is a wet process. Dry resist deposition was first demonstrated really in Korea in volume. And by going with a highly controllable dry process, we are really innovating not only at the material, but also at the material photon absorption level to try to make EUV more productive, more scalable, and more accessible for a lot more applications. In addition to kind of the highly controllable aspect of it, the nice thing about dry resist processing is it provides 5 to 10x reduction in material consumption, as well as more than 2x power reduction per wafer pass, enabling some of the biggest challenges in terms of EUV productivity, but also some of the challenges from an environmental perspective in terms of energy and material consumption that we've been experiencing. Another technology that we believe will become key for some of the innovations of the future is going to be selective etch. Lam selective etch technologies are already in use as some of the major Korean semiconductor leaders in both memory and logic. And it is key for 2 aspects. As FinFETs run out of scaling capability and we're moving to gate-all-around or nanosheets, we need to have the technology to be able to etch these materials selectively and isotopically. Similarly, as we're on the verge to moving to 3D DRAM, we have the same need to be able to create these complex vertical stacks as we move from planar to 3-dimensional DRAM. Finally, and this may not be kind of an incredible innovation, we think that ALD, atomic layer deposition, is also one of the key technologies that will help, foster and promote kind of this continued innovation in a productive fashion. But ALD is not a breakthrough. ALD is a well-known technology. What the breakthrough maybe is to create productive ALD so that it can be used productively in a high-volume environment. As the dimensions are shrinking, we are facing ourselves with having less and less real estate for example, contacts, and the contact resistance continues to go up. Through an enhanced ALD process, we have developed a barrier-less solution that allows us to maximize the cross-section that is being used with the conducting material and allows us to minimize the resistance impact on this. Now, the challenge here is to do it productively. And we believe the breakthrough in this productive ALD is really driven by the quad architecture that we're using that allows us to be very, very efficient and extremely productive in our ability to use ALD in high-volume production. So we talked a little bit about kind of R&D and technology and the development of these new technologies in close proximity to the customers and some of the things that Lam Research is doing to help foster this. And often the technology takes the limelight, but as an operations person, I think we also need to show innovation in our manufacturing strategies and our supply chain strategies. If nothing, the past several years between the COVID challenges, as well as the supply chain challenges that we experienced last year, these things have really highlighted kind of a need for innovation in the way we approach our manufacturing and supply chain strategies. So it may surprise some of you, but Lam is the largest producer in Korea of front-end semiconductor capital equipment. We've been actually ramping 3 factories and 2 warehouses in the Gyeonggi province, and we will continue to do so. Since its inception, we have ramped very aggressively, actually over 200%, the output from these factories in Korea, with the objectives of servicing our local Korean customers primarily. It allows us to have a very flexible environment that addresses all the product lines that we have at Lam Research, but also flexible enough that depending on the demands and the balancing between logic and memory, for example, we have the ability to change the production aspects and provide our customers what they need. Through kind of like the COVID challenges, through the supply chain disruption, through the transportation challenges that we experience, our highly skilled Korean team has been able to continue to grow this organization, grow the output, as I said, over 200% over the past several years. And we expect that our Korean manufacturing team will actually deliver before the end of this year its 11,000th tool to the industry and to our customers in Korea. But we've also, beyond just the manufacturing, we've also been investing in our supply chain and localizing our supply chain. Why are we doing this? Well, in Korea, for example, we have increased by nearly 200% our investment with local suppliers, and we plan to do more in the future. The objective is twofold. One, it helps with speed to our customers. It reduces the time that it takes us to get parts and to assemble systems ultimately for our customers. What used to take weeks can now take days in what we do this, providing flexibility and responsiveness in our manufacturing and supply chain strategy. The second thing is it really is very well aligned with our environmental objectives of being carbon neutral by 2050. Simply because transporting these large pieces of equipment by plane is not automatically the best option to do this. And when we had challenges with transportation disruption over the past 2 years, we saw the impact that it could have to the industry to do this. So we think that localized supply chain, and in addition to localized manufacturing, will help with honestly speed and reducing cycle times and bringing some of this technology faster to our customers and to their fab environment, but also addressing some of the environmental challenges that have been plaguing us for kind of a long time in just the manufacturing approach that we've been using. So we've talked a lot about kind of our approach to R&D investment, close to the customer with close collaboration to reduce the cycle times, and bringing these new technologies and this new hardware faster to production. We've talked about this close to the customer approach of manufacturing and supply chain, also kind of addressing these types of cycle time, reduction and helping grow innovation faster. But our job is not completely done until we have kind of delivered this technology in a reliable fashion with high productivity and high availability in the fabs of our customers. So the way we do this is by creating fundamentally smarter tools and bringing equipment intelligence to the tools and to the equipments that we are providing. The complexity of these tools, the number of parameters that we have to deal with on each of the tools in terms of matching them, the variation in terms of incoming wafer properties, the variation in terms of chamber conditions that some of these pieces of equipment may have, has made it very, very difficult for a human being to actually be able to manage and track all these parameters. We're talking about hundreds of parameters, in some instances, thousands of parameters. Today, we built in machine learning algorithms directly into our system so that they can make decisions and collect the data across these parameters and provide the information to semiconductor makers as well as the actions to kind of correct what needs to be done. In addition, we have provided analytic and diagnostic tools that continue to provide extremely quick leveraging, again, machine learning, AI, the ability to very quickly get to the source of the problem whenever there is a problem, and there will be a problem. So we think this is revolutionizing, ultimately, the chip-making process. Sensei, our latest edge platform, was built with these principles in mind. It has unparalleled system equipment intelligence delivering best-in-class wafer performance and optimized fab footprint. Actually, if you look at the history of Lam Research, this capability of building this equipment intelligence, making the systems self-aware, self-adaptive, and self-maintaining, has really created a product at Lam that is the fastest ramping product in the history of our company. It really shows where the industry is going, and I think more of it needs to be done. But today, not everything will be fully automated, and there will need to be, from time to time, kind of a need for human intervention. So how do we do this? The problem with human intervention, it's human variability. Depending on training, depending on capability, you introduce another variable in the process that can be very, very challenging. We believe that the combination of not only advanced diagnostic and analytic tools built into the stream of data and big data that's coming out of these systems, together with automation, is the approach that we can go with to help minimize this human variability in the maintenance of these tools. So just to give you an idea, a tool that does not come back to production after a routine maintenance is extremely disruptive to the production of the fab. To this end, Lam is deploying cobots working in tandem with our human service engineers to take on the task of maintenance. And what you're seeing here on the screen is a particular maintenance where one of our cobots is being docked by these, our field service engineers to one of our tools, and it takes on the challenge of cleaning a chamber or dirty chamber, a process that is time-consuming, very challenging, and historically been done by a human being using a Scotch-Brite pad, not the most predictable or repeatable approach to cleaning a chamber. The nice things about cobots is they're ideally suited to do these types of activities. Not only can they pick the right tool, to do the job, but they can also optically analyze the surface of the chamber and then decide whether more cleaning is required or less cleaning is required. And what is important is that the job be done right the first time, and cobots are perfect for this. They will ensure the job is repeatable, and they will eliminate that variability that could be introduced if humans were to do this. So it comes as no surprise that technology advancement is extremely important to the world economy. We have seen kind of the challenges that gaps, can create, especially in the past several years. And I think it will continue to be that way. I think we must continue to work together. And I think from an equipment perspective, we believe that three aspects are kind of key. Very tight collaboration on bringing new technologies and new hardware faster to solve some of these challenges, using not only close collaboration workspaces like the KTC lab that I mentioned earlier, but also through kind of mutual investments of R&D with mutual respect of intellectual property. So these R&D investments continue to bear fruit on it and deliver on the technology innovations that we're looking for. The second aspect is we must bring much better innovation to our manufacturing and supply chain. And in supply chain, we need to bring much better resiliency than what we experienced in the past year. And that should be throughout the entire ecosystem. I think it's very important. And then finally, we need to bring equipment intelligence to bear to optimize the fab performance of these pieces of equipment. And I think this is most ideally done through, again, machine learning algorithms, AI, as well as bringing automation into the fab for some of the repeatable tasks that we may have. So to conclude, we believe that through these actions, this is probably the way we can continue on this path of innovation. so that the next 60 years are as good as the previous 60 years in terms of kind of like rapid innovation, and so that together we can enable ourselves, but also every human or every industry to fundamentally achieve tomorrow what may seem kind of unimaginable today. So with this, I'll bring my talk to an end, and I'll take any questions. Thank you. 감사합니다.